Hello everyone, I'm Mary Swarnalatha, working as Assistant Professor in the Department of Electronics and Communication Engineering. In today's lecture, we are going to discuss about the autocorrelation of the system response and the cross correlation between the input and output of the system. So what is an LTA system? So LTA means linear time invariant system. A system is said to be LTI if it is satisfying both the linearity property and time invariant property. So what is a linearity property? A system is said to be a linear system if it is satisfying both the homogeneity and superposition principle, or else you can define a linear system as the response is nothing but here transformation. The response of weighted sum of inputs is equal to the sum of the weighted response. Sum is nothing but here plus. So sum of the weighted responses. So response of the input signal x1 of t is nothing but what? T of x1 of t. And the response of the input signal x2 of t is t of x2 of t. And sum of what? Weighted responses. It means each response has been multiplied by some weight. So this is a definition of a linear system. A system is said to be linear if the response of weighted sum of inputs is equal to the sum of its weighted responses. Then the system is said to be linear system. Next, what is time invariant system? A system is said to be time invariant if its input-output characteristics does not vary with time. Then you can say that the system is time invariant. What does it mean? For example, x of t is a input signal and the response of the system can be written as by t of x of t. Here, what is t indicates? T indicates a transformation. It may be any operation. You can perform any operation and the given input signal so that you are getting the response of the system as y of t. Now what is time invariant system? The input-output characteristics should not vary with time. Then it is called as what? Time invariant system. Now if the input has been delayed, what is here? X of t is input signal. Then what is x of t minus k? It is a delayed input. It is what? Delayed input. And the response of delayed input. Let us say I am representing by y of t comma k. Now what is y of t comma k? It is nothing but it is a response of the system due to the delayed input. And I am delaying the output. So what is the response of the system or the output system is nothing but y of t. Then what is the delayed response is nothing but what? Y of t minus k. Now if y of t minus k is equals to y of t comma k. What does it mean y of t minus k? It is a delayed response of the system or delayed output of the system. The delayed response of the system is equal to the, what is y of t comma k? It is the response of the system due to the delayed input. Then it is called as what? Time invariant system. Or else it is called as what? Time variant system. Time invariant means what? Here the input characteristics are changing and the output characteristics are also not changing. So the input and output characteristics are not changing with respect to time. It is called as what? Time invariant system. If the system is satisfying both the linearity property and time invariant property, then it is called as what? LTA system. Linear time invariant system. Now, this is the LTA system and x of t is the input of the system and its response is what? Y of t. So, what is the system? The system is called as the LTA system and the impulse response of the system is h of t, let us say. Then, what is the response or the output of the LTA system can be written as the convolution of the applied input signal and its impulse response. So this is the equation for the response of the LDA system. What is the equation for response of the LDA system? Y of t is equals to x of t convolution h of t. Now, here what is h of t is called as what? It is called as the impulse response of the system. What is impulse of the response of the system? If the input to the system is impulse input, then the response of the system is called as what? Impulse response. So, this is the definition of what? Impulse response, and the response of LDA system can be written as the convolution of the input and the impulse response of the system. So, this is a brief discussion about the LDA system. Now, we can apply the same concept to the random process also. So, here for the LDA system, I can apply a random process or random input x of t. So, this is the LDA system, and the response of the LDA system, if the input is random input, then the response or the output of the system is also random. So, you extend the same concept of LDA system to the random process also. So, for the LDA system, you apply the input as the random input x of t, and you'll get the output y of t. Then, how could you write down y of t as? Y of t is equals to x of t convolution h of t. Here, what is x of t is called as the random process, a random input, and h of t is called as the impulse response. And this is called as what? The response of the LDA system due to the random input. Therefore, what is y of t is equals to x of t convolution h of t. Now, for random process, we can calculate the statistical properties like mean square value, correlation, autocorrelation, you can calculate, and then you can calculate cross correlation. So, all these statistical properties, similarly, you can calculate the autocovariance, you can calculate the cross covariance, like that. You can calculate the statistical properties with respect to the what? The random process. So, in the previous lecture, we have calculated the mean of the response of the system, and then we have calculated the mean square value of the response of the system we have calculated. In today's lecture, we'll calculate the autocorrelation of the response of the LDA system, and then we'll calculate the cross correlation between the input and the output of the LDA system. So, first we'll go for autocorrelation of LDA system. So, what is the autocorrelation formula? Already we have seen the autocorrelation of a random process y of t is nothing but what? E of y of t into y of t plus tau. Here, what is y of t? Y of t is nothing but what? It is the response of the LDA system. What is this? This is the LDA system, and the input applied to the LDA system is a random input, and the output or the response is called as what? The random output y of t. Now we are calculating what? We are calculating the response, the autocorrelation of what? The response of the system. Here, what is the response of the system can be represented by y of t. Then what is the autocorrelation of the response or the output of the LDA system can be represented by what? R suffix yy. So, autocorrelation of which function you are calculating? You are calculating the response of the system. Therefore, Iyy of t comma t plus tau is equals to what? Expectation. Here, what is E indicates the expectation. It is also called as what? Statistical average, or it's also called as what? Mean. So, E of y of t into y of t plus tau. Now, for the LDA system, if the input applied is the random input x of t, then what is y of t is equals to, how can I write down this as? X of t convolution h of t. Therefore, what is y of t is equals to x of t convolution h of t, or else it is also called as h of t convolution x of t, because the convolution is satisfying the commutative law. A star B is equals to what? B star A. Therefore, what is y of t is equals to the response of the entire system is nothing but what? The convolution of the impulse response of the system and the random input x of t. Therefore, what is y of t is equals to, substitute here h of t convolution x of t. Then what is y of t plus tau? Just replace t by t plus tau. Then what is y of t plus tau is equals to x of t plus tau convolution h of t plus tau. And similarly here also h of t plus tau convolution x of t plus tau. Now, so write down y of t plus tau also. What is y of t plus tau? H of t plus tau convolution x of t plus tau. Now, we write the formula for convolution. What is the formula for convolution of two signals? These are the continuous time signals. Therefore, you can write down the convolution formula as integration minus infinity h of lambda 1. Here, lambda 1 is a dummy variable. So, in place of lambda 1, you can replace by any other variable other than the variable t. So, what is h of t convolution x of t is nothing but integration minus infinity. Why I have taken here integration? Because the type of signals here are continuous time. That's why here I have taken integration. In case of discrete random process, discrete signals, in place of integration, I have to take the summation. Then what is the formula here? Integration minus infinity h of lambda 1 into x of t minus lambda 1 d lambda 1. So, in place of lambda 1, if you want to replace, can replace by any other variable also. And similarly, what is h of t plus tau convolution x of t plus tau? So, integration minus infinity. So, in place of lambda 1, I have used another variable lambda 2. So, h of lambda 2 into x of, if t is there, I am writing here t minus lambda 1. In place of t, here I am having t plus tau. Then what I have to write down here? T plus tau minus lambda 2 into what? D lambda 2. Now, rearrange this equation as integration minus infinity. So, write down this equation. Integration minus infinity and integration minus infinity h of lambda 1, h of lambda 2. And this statistical average, the expectation always will find out with respect to the random process. So, here in h of lambda 1, h of lambda 2 are not the random process. They are the impulse response. And here x of t minus lambda 1 and x of t plus tau minus lambda 2 are the random process. That's why you apply this expectation for x of t minus lambda 1 and x of t plus tau minus lambda 2. Then you write down the equation as integration minus infinity and integration minus infinity h of lambda 1 into h of lambda 2 into expectation of x of t minus lambda 1 into x of t plus tau minus lambda 2 into what you are having there? D lambda 1, D lambda 2. Now, what is the function? Expectation of x of t minus lambda 1 into x of t plus tau minus lambda 2. So, what do you call this function as what? Autocorrelation function. So, autocorrelation function of which random process? X of t. So, that's why replace this by what? R. R is nothing but correlation. And XX is nothing but auto, because here having both the random process x of t only. That's why R excess of T1. If you have T1 and T2, you write down T1 comma T2. Now, in place of T1, what you have here? T minus lambda 1. In place of T2, what you have here? T plus tau minus lambda 2. Into what you have here? D lambda 1, D lambda 2. Now, if you consider the random process x of t is a wide sense stationary random process. So, what do you mean by wide sense stationary random process? Random process is said to be wide sense stationary if it is satisfying only two statistical properties are not varying with time. There is nothing but the first condition is what? The mean of the process should be constant, and there is nothing but u of x of t equals to x bar for all values of t. And second one is what? The autocorrelation function should be a function of only the time difference. Here, what is the time difference? What is the first time here? T minus lambda 1. What in place of T1? What you have here? T minus lambda 1. In place of T2, you are having what? T plus tau minus lambda 2. Then what is T2 minus T1 is equals to what? T plus tau minus lambda 2 minus T minus lambda 1. That equals to what? Here T will get cancelled. Then you will get tau plus lambda 1 minus lambda 2. Therefore, if the random process x of t is a Whitesian stationary, then the autocorrelation function is a function of only the time difference. Therefore, you can write out this equation as RHS of the time difference of these two times. Nothing but what? Tau plus lambda 1 minus lambda 2 into what you have here? D lambda 1, D lambda 2. So, this is what? This is nothing but the autocorrelation function of the output of the system or the response of the LTI system. If you observe this equation, is it depending upon the time t? No, it is a function of only tau. Therefore, the autocorrelation of the response of the system is also what? A function of only tau, the time difference tau only. It means if the random process x of t is Whitesian stationary and the Whitesian stationary random process x of t is applied to the LTI system, then the response of the system y of t is also again Whitesian stationary process itself. Now, this equation is nothing but it is a two-fold convolution. Nothing but what? Two-fold convolution. So, this is again write this as what? The convolution of the random process x of tau and h of tau and h of minus tau. So, this is not x here. This is a autocorrelation function RHS of tau. So, RHS of tau convolution, h of tau convolution, h of minus tau. So, this is a autocorrelation of response to the system. You can rewrite the equation by like this, or else you can represent in terms of convolution symbol by what? RHS of tau convolution, h of tau convolution, h of minus tau. It is a two-fold convolution. So, two-fold convolution of which signals? The autocorrelation of the random process x of t and the impulse response h of t and its folded signal h of minus tau. So, RHS of tau convolution, h of tau convolution, h of minus tau. Therefore, this is autocorrelation function. And similar manner, we will calculate the cross correlation of input and output. What is a input to the LTI system? This is the LTI system. And what is the input to the LTI system is x of t. And what is the output? Y of t. Now, what you have to calculate? Previously, I calculated the autocorrelation of the response of the system itself. Now, what you are calculating? You are calculating the cross correlation. Cross is nothing but what? Between two different. Correlation nothing but what? Measuring the similarity. So, measuring the similarity between the applied input signal and the response of the system is called as what? Cross correlation of input and output. Now, I want to calculate the cross correlation between the input x of t and the output y of t. Then what is cross correlation means? You have to take two different. So, cross correlation between what? The input and output. So, Rxy. So, Rxy of t comma t plus tau is nothing but what? Expectation of x of t into y of t plus tau. Now, what is y of t? You know that? Nothing but what? The convolution of the input signal x of t and its impulse response. Because the response of the LTI system, you can write it down as what is y of t is equals to the applied signal x of t, the random signal x of t and its impulse response h of t. Therefore, what is y of t? X of t convolution h of t, or else write this as what? H of t convolution x of t, because this is a convolution satisfies the commutative law. And similarly, if you want y of t plus tau, then what do? You just replace t by t plus tau here. Then what is y of t plus tau is equals to x of t plus tau convolution h of t plus tau. Or the equals to what? So replace t by t plus tau. There is nothing but h of t plus tau convolution x of t plus tau. Now, you substitute y of t plus tau here. So, expectation of x of t into, so you replace this y of t plus tau by h of t plus tau convolution x of t plus tau. It equals to expectation of x of t into. Now, you write down the convolution formula. What is the convolution of two continuous time signals? So, integration minus infinity h of lambda. You can replace this lambda by any other dummy variable also. H of lambda into x of t plus tau minus lambda into d lambda. So, this is a convolution formula. So, if you are having only t, then write down as x of t minus lambda. If you are having t plus tau, then in place of t, write down as t plus tau. So, t plus tau minus lambda. If you want, you can replace this lambda by any other variable also. This is a convolution formula. Then, what is the statistical average or else the expectation? Always we'll calculate with respect to the random process only. So, in this, which is the random process? X of t and x of t plus tau minus lambda is a random process. So, remaining you can bring it outside. Then you can rewrite on the equation as integration minus infinity h of lambda. So, into expectation of x of t into x of t plus tau minus lambda into d lambda. Now, what is this function? What is u of x of t into x of t plus tau minus lambda? This is called as what? Autocorrelation, because x. So, it is called as what? Autocorrelation function. Therefore, you can rewrite on this equation as what? Rxs of t comma t plus tau minus lambda. What is the first value having? T. Second one is t plus tau minus lambda. So, Rx of t comma t plus tau minus lambda. If you consider x of t is a Waitzian stationary, then the autocorrelation function is a function of only the time difference. It will not depend upon t, but depends upon the time difference. What is the time difference here? T plus tau minus lambda minus t is equals to what? Tau minus lambda. Tau minus lambda. So, equals to what? Therefore, integration minus infinity h of lambda into Rxs of tau minus lambda. Now, what is this equation? This is nothing but what? Convolution of h of tau and Rxs of tau. Therefore, what is the cross correlation between the input and the response to the system? Rxy of tau is equals to what? H of tau convolution Rxs of tau. And similarly, if you want to calculate the cross correlation between the output and input, previously we have written for the input and output, nothing but Rxy of tau. Now we are writing what? The output and input, there is nothing but here Ryx of tau. So, Ryx of t comma t plus tau, nothing but expectation of the output and then input. So, u of y of t into x of t plus tau. So, what is y of t? It is a response to the LDA system, that is nothing but x of t convolution h of t, or else it is also called as h of t convolution x of t also. Now, substitute the y of t, the response to the LDA system, by what? H of t convolution x of t. Then what can I write down here? The cross correlation between the output and input as E of h of t convolution x of t into what you have here? X of t plus tau. Now, you write down the convolution formula. What is the convolution formula here? Integration minus infinity h of lambda into x of t minus lambda d lambda. Now, the expectation, the statistical average will be applied only to the random process. In this, it is a random process, x of t plus tau and x of t minus lambda is a random process and is a constant. The impulse response is a constant. So, bring it outside. Then you can write down this as integration minus infinity h of lambda into e of x of t plus tau into x of t minus lambda into what you have here, d lambda. Now what is this function? This is nothing but what? Correlation. So is it auto cross? Since both are x, it is called as what? Autocorrelation of the random process x of t. Therefore, what is e of x of t plus tau into t minus x of t minus lambda? That is the what? Rxs of t plus tau comma t minus lambda. Now, if you consider the random process x of t is void and stationary, then it is a function of only the time difference. What is the time difference here? T minus lambda minus t plus tau. That is nothing but what? Minus lambda minus tau. So, minus tau minus lambda. Now, so you can write down this equation as if you take minus common here. Then what can I write down here? Minus of tau plus lambda. So, this is nothing but what? The convolution of h of minus tau because it is minus. So, h of minus tau convolution Rxs of tau. Therefore, what is the cross correlation between the response of the system and the input of the system in nothing but what? R by x of tau is equals to h of minus tau convolution Rxs of tau. Therefore, in today's lecture, we have seen the autocorrelation of the response to the system. After that, we have seen the cross correlation between the input and output of the LTI system. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.